Hello students, welcome to AIMS in your online classes. This is a chemistry session. Here we are discussing about the chapter structure of the atom. Now we are going to see in this session about Bohr's model of atom. Okay. In order to overcome the limitations of Rutherford's model, actually before this we have seen different models proposed by J. Thomson and Rutherford, isn't it? We told some we discussed about some 10 limitations from the Rutherford's atomic model. So, in order to overcome these limitations of Rutherford's atomic model, in 1913, Niels Bohr put forward a thought that electrons can be found only in certain energy levels or regions around the nucleus. So, electrons must gain energy to move to a higher energy level, or they must lose energy to move to a lower energy level. Until unless they gain or lose energy, they retain in the same energy level and they continuously revolve around the nucleus in the same shell or energy level. Let us take an example. Think of a book. Think of books arranged in a bookshelf. See here, books are arranged in the bookshelf. They can be placed on a higher shelf or a lower shelf, but never between the shelves, isn't it? Books can be arranged in the higher shelves or lower shelves, but they cannot be arranged in between the shelves. In the similar way, electrons also will be arranged either in the higher energy levels or in the lower energy levels, but no electrons exist in between the shells. Okay, that was explained by Niels Bohr. Restricting the path of the electron inside the atom like this, Niels Bohr made the following postulates about the atomic model of the atom. Now let us see the postulates here. First one, electrons revolve around the nucleus with a definite energy in concentric circular orbits called stationary orbits or shells. These orbits are denoted as K, L, M, N and so on, or 1, 2, 3, 4 and so on. In this way, these are denoted. So see, at the center there is nucleus with a complete positive charge and mass. Around that, electrons are revolving in the concentric circular paths, which are denoted as 1, 2, 3, 4 and so on, or KLMN and so on. The orbit which is nearest to the shell, nearest to the nucleus, is denoted with the symbol K or 1 and so on. Okay. The electrons have the least energy in the K shell of the atom, followed by L shell and M shell, etc. See, the shell which is nearest to the nucleus, we told here first shell or K shell. The electrons present in this shell will be having least energy. And next L shell electrons, and then M and so on. Means as the distance between the nucleus and the orbit increases, the energy of the electrons present in those orbits gradually increases. Now we can say the electrons present in the first shell or K shell are having the least energy. As long as electron revolves in the same circular orbit or energy is neither radiated nor absorbed by the electrons. There will be the fixed energy, definite energy. Until and unless it is revolving in the same orbit, its energy won't be changed. It neither gain energy nor lose energy. And this is the reason why electrons do not fall into the nucleus. That's why as these electrons are not radiating or not gaining energy, they will be continuously revolving in the same orbit and they are not being fallen into the nucleus. Energy of the electron changes only when it moves from one orbit to another orbit. Energy is absorbed when an electron jumps from an inner orbit to outer orbit and vice versa. Okay, energy changes occurs only when electrons jumps from one orbit to another orbit. If electron jump from lower orbit to higher orbit, we know the lower orbit is having accommodating less energy. The electrons in the higher orbit should have greater energy. That's why when electron jumps from lower orbit to higher orbit, it will gain energy. If an electron jumps from higher orbit to lower orbit, that electron will radiate certain amount of energy and comes into the lower orbit. So Niels Bohr could successfully explain the properties of hydrogen atom like the atomic spectra emitted by hydrogen atom employing this model. Okay, he explained about the atomic spectra and models of the atoms like hydrogen and hydrogen like atoms. Okay, means which are containing only one electron with them. But this model could not predict the spectra of atoms or ions with more than one electron. So this we can say the major limitation or drawback of Bohr's atomic model. His theory, his proposals successfully explain the atomic spectra or atomic models of the atoms which are containing single electron in them. Hydrogen or hydrogen like species like He plus Li plus 2 etc. But this atomic theory or atomic spectra would not explain this atomic model could not explain the atomic spectra of atoms or ions which are having more than one electron in them. So here one point we have to notice that you must have noticed that none of the atomic models that we have been studied till now, like Thomson's atomic model, Rutherford's atomic model, and even in the Bohr's atomic model also, we have it is not mentioned about the neutrons. Did you see? Even while explaining about the shells and orbits also, we told at the center part of the atom there is positive mass with protons. Around that electrons are revolving, we told. But we did not mention about the neutrons. No, we didn't see about the neutrons discussion in these all atomic models. This is because neutron was discovered later in 1932. Okay, it was discovered so far later. Until Rutherford's and Bohr's time, the neutron had not been discovered. While they were giving their atomic models, Rutherford and Bohr, neutrons were not yet discovered. Neutron was discovered nearly 2 decades later, isn't it? Bohr's theory was given in 1913, whereas this neutron was discovered in 1932 by Chadwick. So after 2 decades of almost they were discovered. Till then, they did not discuss about these neutrons presence in the nucleus. They know as only protons are present inside the atom, and the total mass is because of these protons. Because electrons mass was known as negligible. Okay, except hydrogen atom, the atoms of all other elements contain neutrons in their nuclei. This also you can see one of the drawbacks, one of the reasons for the limitation of Bohr's theory. Okay, next, distribution of electrons in the orbits. The systematic arrangement of electrons in different shells of atoms is called electronic configuration of that element. So we are telling the at the center part of the atom, nucleus is there which contains complete positive charge and mass. Around this, electrons are revolving in the concentric circular paths called orbits. But how many electrons are being revolving in each orbit? That explanation, that arrangement of electrons in systematic way is called electronic configuration of that element. For writing the electronic configuration of an atom, we must know the following things. If you know these points about that atom, we can understand how the electrons are arranged in that atom. We can write the electronic configuration for that. One of them is total number of electrons present in that atom. So this can be known based upon the atomic number of that element. If you know atomic number will be equal to number of protons, which is also equal to number of electrons. Okay, so we can understand, we can find the number of electrons based upon its atomic number. One more point to be known is maximum number of electrons that can be accommodated in each shell of the atom. So if you know this, then we can understand how these electrons are arranged in the different shells of an atom. So Bohr and Bury together proposed certain rules for better understanding the electronic configurations of atoms. They are, first of all, let us see here. The maximum number of electrons that can be accommodated in a shell is given by the formula 2a_n square. So here, to understand the electron configurations of the atoms, Bohr and Berry together they have proposed certain rules. So by following these rules, we can understand the electron configuration of any kind of atom. So one of them, for first one of the points is the maximum number of electrons that can be accommodated in a shell is given by the formula 2n square, where n is a number of shell. According to this formula, maximum number of electrons in first shell, that is K shell. So K shell means first shell, means in the place of n we have to substitute 1. It becomes now 2n square, means 2 into 1 square, that is 2. So first shell can accommodate only maximum of 2 electrons for any atom. In a similar way, maximum number of electrons that can be accommodated in the second shell, that means L shell. So how can we find? In the formula 2n square, in the place of n, if we substitute 2, we get maximum number of electrons that can be accommodated in the second shell as 8 electrons. For all the atoms, second shell can accommodate a maximum of 8 electrons. Okay, let us see the remaining shells also. Some third shell can accommodate, that is M shell can accommodate 18 electrons, because if we substitute in the place of n 3, we get it as 18. And the fourth shell can accommodate 32 electrons, that is N shell can accommodate 32 electrons of maximum. Even though they can accommodate these many electrons, the next rule is the outer shell of an atom cannot have more than 8 electrons, even if it has a capacity of holding more electrons. Even though it has a capacity for holding more number of electrons, the outermost shell of an atom can have maximum of 8 electrons only. If it is filled with the 8 electrons, remaining electrons will go into the one more outer electron, outermost orbit. Okay. Next, for example, if M shell is the outermost shell of an atom, that means third shell. If the third shell is the outermost shell of an atom, it can accommodate maximum of 8 electrons only, but its capacity is 8 electrons, although it has a capacity of accommodating maximum of 18 electrons, isn't it? So for any shell, if it is the outermost shell, it can accommodate a maximum of 8 electrons only, even though its capacity is more than that. If it is filled with 8 electrons, the remaining electrons will go into the next orbit. Thereafter, filling 8 electrons, again this shell will be completely filled with the remaining accommodation. Okay, this is one of the rules. Next one, an atom becomes stable if its outermost shell has 8 electrons, or if it has only one shell containing 2 electrons. So it is observed the atoms with 8 electrons in their outermost shell are being more stable. What is meant by her outermost shell? We are using the word outermost shell, means the last shell of an atom. If has only one shell, that itself it is called outermost shell. If it is only one shell, if it is filled with the 2 electrons, that atom is observed with more stability. If it is having more than one shells, out of those, the last shell, if it is having 8 electrons filled, then that atom is being more stable. Actually, this is called octet configuration. Octo means 8 electrons. So the atom with the 8 electrons in the outermost shell is being more stable, least reactive. Okay. Next rule. The penultimate shell can accommodate a maximum of 18 electrons, even though its capacity is being more than that. Penultimate shell means the shell which is last but one. From the outside, of an atom, if it is observed, last shell is called outermost shell, just now I told, and the last but one shell is called penultimate shell. Suppose an atom is like this with a different number of shells. So out of this, if we come from the outside, the last shell is called outermost shell, the last but one shell is called penultimate shell. Okay, the penultimate shell of an atom can accommodate a maximum of 18 electrons even though its capacity is more. Okay, they are the rules given to understand the electronic configurations of the atoms. These were given by Bohr and Bury together. One more it is. Electrons do not enter into a new shell before the inner shell is completely filled. Yes, this is also one. First, electrons will occupy the lower energy levels. After completely filling these lower energy levels only, electrons will enter into higher energy levels. So by using these all rules, we can understand the electronic configurations. Now let us one example. Let us take the example of oxygen, where atomic number is equal to 8. So since the number of electrons is equal to number of protons, its number of electrons will be 8. It has 8 electrons. Now let us follow step by step. Step 1. The K shell can accommodate, that is first shell, can accommodate a maximum of 2 electrons. So the first 2 electrons fill the shell of N is equal to 1. So for oxygen, the first 2 electrons will fill the first shell like this. So first 2 electrons will be filled into first shell of oxygen. Suppose if it is nucleus. Now in the second step, let us see. The other 6 electrons will fill the higher shell, that is the next shell, N is equal to 2, or we can say L shell. So after completion of 2 electrons, totally there are 8 electrons, 2 completed in the first shell, there are 6 more electrons, so they fill the second shell. This we can say configuration of oxygen. Now we can see then the electronic structure or electronic configuration for oxygen atom is written like this. First we come from lower energy level. In the lower energy level there are 2 electrons. So first we write 2. Come on. Next shell number of electrons will be written later. So 6 electrons are the next shell. So 2 comma 6. This is called electronic configuration of that element. This is electron configuration of oxygen 2 comma 6. Okay, in this way electronic configuration is written by following Bohr-Bury rules. Now let us see here some arrangement of electrons in the certain elements. So first 18 elements are mentioned here. Just now we have seen arrangement of oxygen. Okay, so first shell is having for all the atoms only 2 electrons, and second shell can accommodate maximum of 8 electrons. So these atoms we can say stable elements. The atom with the 8 electrons in the outermost shell is more stable, we told. And if it is having only one shell, if it is having 2 electrons in that, then that is also more stable. This configuration is called octet configuration, and it is called duplet configuration. Now let us see valence electrons and valency of the atoms or elements. Valence electrons means the electrons present in the outermost shell or the last shell, which is also called valence shell of an atom, are called valence electrons. For example, the number of valence electrons of sodium, because atomic number of sodium is 11. If you write its configuration as by following these Bohr-Bury rules, we get it as 2 comma 8 comma 1. Now for sodium, how many electrons are there in the last shell or valence shell? Only one electron. Hence we say its valence electrons are 1. The number of valence electrons for sodium is only 1. Let us see one more example. The number of valence electrons of fluorine. Atomic number of fluorine is 9. If you write the electronic configuration for 9, you get it as 2 comma 7. Now for this valence shell is this. How many electrons are there in the last shell here? There are 7 electrons. Now we can say number of valence electrons for fluorine as 7. Okay, this is about valence electrons. The electrons present in the last shell or valence shell, which is also called outermost shell of an atom, are called valence electrons. Now the valency. It is defined as the combining capacity of an element. The combining capacity of an element is called its valency. Let us understand this with the explanation. Elements other than noble gases contain less than 8 electrons in the outermost shell. Just now I told the atoms with the 8 electrons in the outermost shell are being more stable and they are called noble gases. Other than these, remaining all elements they have less than 8 electrons in their outermost shell. So we can say these elements are chemically more reactive and least stable, highly reactive elements. They tend to acquire the stable electromost electron configuration of noble gases either by gaining or losing or sharing electrons with other atoms. So as they do not have 8 electrons in the outermost shell, they also will try to attain 8 electrons in the outermost shell by one of these, either by gaining electrons or by losing electrons or by sharing electrons with other atoms. In this train, thus the number of electrons gained, lost or shared by an atom to complete its octet or duplet is called valency or combining capacity of that element. Meddling the elements with the less than 8 electrons in the outermost shell being reactive, and these also will try to attain 8 electrons in the outermost shell either by gaining or losing or sharing electrons we told. So here the number of electrons gained, lost or shared by an element to complete its octet is called its combining capacity or its valency. Okay. Elements with less than 4 electrons in their outermost shell or valence shell will lose electrons generally. So if the elements are having 1 or 2 or 3 valence electrons, generally those elements will lose those electrons and hence they get octet configuration. And those elements with more than 4 electrons, if they have 5 or 6 or 7 electrons in their outermost shell, those elements will gain electrons so that they acquire octet or duplet configuration. Okay. For example, if we take sodium, just now we have seen its atomic number is 11 and its configuration is 2 comma 8 comma 1. Okay, it has only one electron in its valence shell. Hence this element, this sodium, will try to lose this one electron and becomes stable with the configuration 2 comma 8. See, in the outermost shell it is having one electron. If it is lost, then what happens? Its configuration 2 comma 8. So this 2 comma 8 is one of the stable configurations because now this is the last shell and it is filled with 8 electrons. Octet configuration it is getting. So in this way, valency of sodium is here, the number of electrons lost by it. How many electrons it is losing here? 1 electron. So the valency of sodium is 1. Okay. Let us take one more example. If you see oxygen, atomic number of oxygen is 8 and it has 6 electrons in its valence shell because configuration 2 comma 6. Now as it has 6 electrons in the outermost shell, it needs 2 more electrons to become stable, to make it 2 comma 8, isn't it? So hence it will gain 2 electrons and become stable with 2 comma 8 configuration. So how many electrons it gained here? 2 electrons. Thus the valency of oxygen is 2. So in this way valency can be defined as the number of electrons lost or gained by elements in attaining octet configuration is called their valency. So that's why valency of sodium is 1, valency of oxygen is 2. Valency is just the number which indicates the number of electrons are shared or gained or lost. So just numerical number we represent. Okay, that's about valency. Thank you for watching our video. Please subscribe our YouTube channel Aims Today and visit our website aimstoday.in for latest updates and recorded videos.